vocabulary out of the way, we want to talk about how we can visualize the graphs themselves once we have data. So in this particular lesson, we're going to talk about frequency distributions and the different types of graphs that could pair with those frequency distributions. So let's first talk about frequency tables and relative frequency tables. So both qualitative categorical data and quantitative data can be arranged in frequency and relative frequency tables. A frequency table is a table with two columns. One column lists the outcome or the numeric range, and the second column lists the frequency itself. And the frequency being the number of items that are in that category or numeric range. When the first column contains a numeric range, we call them classes. Now, a relative frequency table also lists one column that has the outcome or the numeric range, and the second column lists the relative frequency itself. This is the proportion of the items in the category or numeric range. Notice that the relative frequency is the frequency divided by the total amount that we have. Let's put this all together. Create a frequency and relative frequency distribution for the data. A group of adults were asked how many children under the age of 18 they had living in their household. The data below represents their answers. So as I look in the table, how many people had 0? Looks like just 1. How many had 1? Let's hear 1, 2, 3. How many had 2? 1, 2, 3, 4. 3. 1, 2, 3, 4, 5. How many had 4? 1, 2, 3, 4, 5. And then there was 1, 2. It also looks like we have 20 total families together. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So the relative frequency is the frequency divided by how many total that there are. So in this case, the number of children with 0 is 1/20th or 5%. Then we'd have 3 out of 20, which is 15%. 4 out of 20, we know is 20%, or 0.20. 5 out of 20 is 25%. We have a second one of those. And then 2 out of 20, which is 10%. In this second one, we also want to create the frequency table and the relative frequency table here for this test scores. Notice now that our test scores are in a bin. And notice that our bin, I've given our bin interval notation as another way to interpret this. And since it's in a range, these are also called classes for different vocabulary, how you might see them. So our test scores between 50 and 59, or between 50 included and 60 excluded. So between 50 and 59, let's see how many are in the 50s. 1, 2, 3, 4, 5. How many are in the 60s? 1, 2, 3, 4. In the 70s, 1, 2, 3, 4, 5, 6. In the 80s, 1, 2, 3, and then the 90s, 1, 2. It looks like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So our relative frequency is 5 out of 20, or 25%, whose test scores are between 50 and 59. We have 4 out of 20, or 20%. 6 out of 20 is 30%. 3 out of 20 we said was 15% on the last page. Oops. And then 2 out of 20, 10%. Well, now that we know how to create a frequency table, let's be able to create some different types of graphs that pair well with frequency tables. The first one is, of course, a bar graph. A bar graph is constructed by labeling each outcome of the data on the horizontal axis and the frequency or relative frequency, depending upon what it's asking, on the vertical axis. Then for each category, we draw a rectangle whose height is the frequency or relative frequency. Create a frequency bar graph from the following data. The table below is the frequency table of the letter grade students received in a calc class last semester. So we have 6 A's, 7 B's, 4 C's, 3 D's, and 2 F's. So down below will be our categories. I have A, B, C, D, and F. These are our grades. And then the frequencies are the vertical axis. 1, 2, 3, 4. I don't think we had anything over 7. You could put 8 if you wanted. And there were 6 A's. So I'm going to draw a vertical rectangle here, the height of which is 6. I had 7 B's. Let's draw another rectangle. I had 4 C's. We had 3 D's and 2 F's. A pie chart is another way we can represent the data. A pie chart is a circle with wedges cut of varying sizes, marked out like slices of pie or pizza. The size of the wedges correspond to the relative frequency. So it's looking really at the percentage of the categories. So we're going to look at this category here. So 27.3% of our pie should be the letter A, the letter grade A. 31.8% of our pie chart or our circle should be B. 18.2% should be a C. 13.6% should be a D. And 9.1% should be an F. So altogether, this should total 100% or one full circle. Now I know that drawing these out, these are not nice decimals, right? There's technology that can help us using Excel or Google in order to create nice, neat pie charts. In My Open Math, you will have the ability to have graphs pre-drawn, and then you get to pick which graph, which pie chart matches. So they'll already be nice and neat for you. But if I think about A is 27%, 27.3%, well, 25% would be a direct 90-degree angle. I need to go just slightly more if I'm drawing this by hand, just slightly more than 25%. So A is 27.3%. Then if B is 31.8%, well, 33% would be a third of the pie. And I specifically have just slightly less than 1/3. So I'm going to go kind of about here-ish. And again, these are not completely accurate, just trying to reason through the size. I then have 18%, 18.2, so think about 20% of the pie. So I'll probably go about here for a C. Slightly less than that should be a D, 13.6%, and then F would be the remainder. So not super accurate, but you get the idea of what they look like. Histogram is constructed exactly like a bar graph, except that the rectangles have no spaces or gaps between the bars. So on the previous one, I had spaces in between my bars. These have no spacing or gaps between the bars. So we've got our classes on the left, the frequency and the relative frequency on the right, which we already had talked about earlier. So let's see if we can't get this drawn out. So I'm going to start with 50 here, 60, 70, 80, 90, 100. These were our classes. They also called them our bins. Remember, so it went from 50 included to 60 excluded. We went then from 60 included to 70 excluded. When I'm writing it in interval notation, just to kind of get an idea. And then we have our frequency on the left. So between 50 and 60, there were 5. I'm going to drop it right down to 60. And then I have, starting no gaps, I had 4. Then we had 7. Then we had 3 from 80 to 90. And then from 90 to 100, we had 2. And these were test scores. We also might want to talk about a frequency polygon. This is also known as a line graph. A frequency polygon is created by placing a point at the midpoint of each class at the value of the category. The point's height is the frequency. Then connect the points with a line. So here's our number of children again and the frequency it happened. So in this particular case, we had, let's see here, 0 children, 1, 2, 3, 4, 5. And then the frequency is under 0, we had 1 child, so 0 goes to 1. 1 had 3. 2 had 4. 3 had 5, 4 had 5, and 5 had 2. And then we use a nice straight line as best we can to connect each of these points. Now, if we have bins or classes, like this last example, we're going to want to place our dot in the middle of where they would be. So in this particular, just as we had set up our histogram, we'll think about going in the middle. So I had set up 50, 60, 70, 80, 90, 100, and our frequency 1, 2, 3, 4. So in between 50 and 59, or 50 and 60, we had 5. So I'm going to kind of go in the middle all the way up to 5. So thinking about where that rectangle would be for our height and put it in the center. Between 60 and 69, we had 4. So again, kind of going in the middle. Between 70 and 79, we had 6. 80 and 89, we had 3. And 90 and 100, we had 2. And then, of course, drawing the nice straight lines connecting dot to dot or point to point.